Hello, this is Yashvin. In this video, I'll be solving paper 4, reading 3, May June 2020, 0620 chemistry. Starting with question number 1. A. The structures of 5 organic compounds A, B, C, D, and E are shown. Answer the questions that follow. Each letter may be used once, more than once, or not at all. 1. Give the letter of the compound, that is propanol. So propanol is the alcohol with 6 carbons. And as you can see over here, this one's the only structure, D, that has 3 carbons and the OH group on the first carbon. Give the letter of the compound that has the empirical formula CH2. So the compound which has carbon and hydrogen atoms in the ratio of 1:2. And C over here has 3 carbon atoms and 6 hydrogen atoms, which is exactly the ratio which we are looking for. 3. Give the letter of one compound that reacts with bromine in an addition reaction. So one compound which has double bonds. So over here I'll go with C. 4. Give the letter of one compound that reacts with chlorine to form the compound shown. So this is the product, and you're supposed to be giving the name of the letter of the compound which would have had a reactant with hydrogen molecule in the place of this chlorine atom over here, and this compound is going to be B. 5. Give 2 letters of compounds that can react with each other to form an ester. So we need an alcohol and a carboxylic acid, and those are D and E. 6. Give the letter of the compound that is in the same homologous series as hexene. So hexene is an alkene, and the only alkene over here is C. Alright. 7. Give the letter of one compound that is an acid. So the acid over here is A, L, and E. You can choose either of them. 8. Draw a structural isomer of the compound D. Show all of the atoms and all of the bonds. So compound D over here is propanol with propane 1-ol. So it has the alcohol group on the first carbon. We can have it on the second carbon in the isomer, and if you draw it on here also in this carbon atom, it will also be counted as the first carbon either way if you draw it over here or here. So the only other solution is if you draw it on the second carbon chain. B. Some acids are described as weak acids. State the meaning of the term weak acid. So an acid is a proton donor. And a weak acid is one which partially ionizes in water. Two, ammonia is manufactured by the Haber process. A. The equation for the reaction is shown. 1. State what is meant by the symbol over here. So this symbol means that the reaction is reversible. 2. State one source of hydrogen used in the manufacture of ammonia. So I'll go with methane over here, which is natural gas. B. Table shows some data for the production of ammonia. Deduce the effect on the percentage yield of ammonia of increasing the pressure of the reaction. So you decrease the pressure from 250 to 100 atmospheres, and so the yield also decreases. But once you increase it, the yield also increases. So as you increase the pressure, the yield of ammonia increases. Increasing the temperature of the reaction. So as the temperature increases, the overall change is a decrease in percentage yield of ammonia. C. Explain in terms of particles what happens to the rate of this reaction when temperature is increased. So increase in pressure results in particles gaining kinetic energy, which means they move faster. And this in turn results to a higher rate of collision. And so a greater number of particles have sufficient energy to react. D. Ammonia is used to produce nitric acid. This happens in a three-stage process. Stage 1 is a redox reaction. 1. Identify what is oxidized in stage 1. So here you can consider either gain of oxygen or loss of electrons. Since both of them are taking place over here, give a reason for your answer. Alright, so we're supposed to be recognizing the substance which is oxidized. In this case, nitrogen is gaining oxygen. So I'll mention nitrogen over here. And the reason is that it gains oxygen. 2. In this reaction, the predicted yield of nitrogen monoxide is 512 grams. The actual yield is 384 grams. Calculate the percentage yield of nitrogen monoxide in this reaction. So you divide the actual yield with the expected yield and multiply the answer with 100. And this gives the percentage yield as 75%. 3. The equation for the reaction in stage 2 is shown. Which major environmental problem does nitrogen dioxide cause if it is released into the atmosphere? So it reacts with the water from a rain and causes acid rain. The equation for the reaction in stage 3 is shown. Calculate the volume of oxygen gas at room temperature and pressure needed to produce 1260 grams of nitric acid. Calculate the number of moles of nitric acid over here. Alright, so we have the mass over here. Moles is equal to mass over molar mass. But we need to calculate the molar mass of nitric acid over here, which is the sum of relative atomic masses of all of the elements in this compound. So hydrogen has 1 and nitrogen has a relative atomic mass of 14. Oxygen is 16, but since we have 3 oxygen atoms, we multiply 16 with 3, and this has the sum of 63. Dividing 1260 with 63 gives the answer of number of moles as 20. Now we need to deduce the number of moles of oxygen that reacted. So here we have the set ratio in the equation. So that means 1 mole of oxygen gives 4 moles of nitric acid. How many moles of oxygen give you 20 moles of nitric acid? So here you simply cross multiply, and that would be 4x is equal to 20. You divide 20 with 4, and so the answer of x, that is the number of moles of oxygen, is 5. Calculate the volume of oxygen gas that reacts at room temperature and pressure. So we have moles, and now we need to find out the volume. Volume is equal to moles multiplied by the molar volume, which is 24 dm cube. And so we get the answer as 120 dm cube of oxygen molecules. E. The reaction in stage 3 is exothermic, which means the energy is released, and so the products are supposed to have an energy level much lower than that of their reactants. Complete the energy level diagram for this reaction. Include an arrow that clearly shows the energy change during the reaction. Alright, so you simply need to draw an arrow which is pointing downwards, and then here you're supposed to be drawing in a horizontal line which has the product over here. 3. Chlorine is in group 7 of the periodic table. A. Two isotopes of chlorine are chlorine 35 and chlorine 37. 1. State why these isotopes of chlorine have the same chemical properties. So they have the chemical properties depend on the outermost electrons in the outermost shell, and since they have the same number of electrons in the outermost shell, they have the same chemical properties. But this new marking scheme requires us to use the phrase electronic configuration. They have the same electronic configuration, so that is going to give you 1 mark. Right. So they have and the new mark scheme requires you to write the phrase they have the same electronic configuration, the 2nd mark. There's just another phrase for saying that they have the same electronic arrangement or that they have a same number of electrons in their outer shell. To complete the table to show the number of electrons, neutrons, and protons in each atom and ion. So here we have chlorine with proton number 17, and since this is a neutral atom, that means the number of electrons and protons is going to be equal. So here we have 17 protons and neutrons. Now you subtract 17 from 35, the mass number, to calculate the number of neutrons, and so that is going to be 18. Now we have chlorine ion, which means the number of protons is going to be less than the number of electrons, since this is a negative charge. And since this is only -1 charge, the number is going to be increased by 1 of electrons. However, number of protons remains the same, and neutrons over here, you subtract 17 from 37, and that gives you the number of neutrons as 20. B1, chlorine reacts with aqueous sodium bromide. Equation for the reaction is shown. State the type of the reaction shown. So as you can see over here, the chlorine is reacting with sodium bromide and giving the products as sodium chloride and bromine. Since chlorine is more reactive than bromine, it can displace bromine to form sodium chloride, and so this is a displacement reaction. 2. Why is there no reaction between iodine and sodium bromide? Once again, iodine is less reactive than bromine, so it cannot displace bromine from sodium bromide. C. Magnesium reacts with chlorine to form magnesium chloride. Complete the dot and cross diagram to show the electron arrangement of the ions in magnesium chloride. If the charges on the ions, the inner shells have been completed. So magnesium loses its outer shell electrons, which were initially 2. So now it gains a complete outer shell with 8 electrons. Since magnesium has lost 2 electrons, that means it gains a charge of 2 plus because it has 2 more protons. Since only one of them goes to each of the chlorine atoms, they only gain a charge of -1 because the increase in number of electrons is by 1. So this electron over here is a 1 which chlorine has gained from magnesium, and this way both of them have now gained a complete outer shell. The hydrogen and chlorine react to form hydrogen chloride gas as shown in the equation. This equation can be represented as shown. Some bond energies are shown in the table. Calculate the energy change for the reaction between hydrogen and chlorine using the following steps. Right, so calculate the energy needed to break bonds. Breaking bonds is the product side, which has hydrogen molecule and chlorine molecule, both of them being diatomic. So we have the energy required for breaking hydrogen and chlorine molecules. So we have the sum of them as 679 kilojoules. And then we have the products forming which give out energy, or which is the exothermic reaction over here. So hydrogen and chlorine has the bond energy of 432, but since we have 2 molecules of hydrogen chloride, we'd write 2 into 432. and that gives the answer as 864 kilojoules of energy. Alright, calculate the energy change for the reaction. So you subtract the energy given out from the energy which was required or taken in. And so this gives the answer as negative 185. This negative sign over here represents that the reaction is exothermic. 4a, filtration and chlorination are two stages in water treatment. State the purpose of each stage. Alright, so filtration removes any solid waste. And any waste which can pass through filtration is removed by chlorination. So it sterilizes or removes any microbes present over here. B. A student uses anhydrous copper sulfate to test the presence of water. 1. What color change is seen if water is present? Alright. So white anhydrous copper sulfate is white in color, and so it changes from white to blue, which is the color of hydrous copper sulfate, hydrated copper sulfate. 2. The purity of a sample of water can be assessed by measuring its boiling point. How is the boiling point of water affected by impurities? It's decreased by, the boiling point of water increases due to impurities. Chromatography can be used to test the purity of substances. The diagram shows the chromatography of a colored substance. 1. How does the chromatography show that this substance is not pure? If the substance was pure, it would not have produced any more than one spot. And since, as you can see over here, there was only one substance, but there are two spots, that means both of them have come from the same substance, and it also denotes that the substance is impure. To draw a circle around the correct RF value for the spot labeled X. Alright, so here you're supposed to be using the formula distance moved by substance divided by distance moved by solvent. My diagram over here is not to scale, but I'll show a demonstration of how you're supposed to be doing it. So you're supposed to be measuring the distance of the substance. In this case, we have the substance X. So it moves from this starting line to this point over here, and you're supposed to be measuring this length, let's say it is 2, and then you're supposed to divide this length by the distance moved by solvent. As you can see, this is the solvent level after it has moved, after chromatography has been run, and then you measure the distance between the solvent line and the starting point. Let's say this is 4, so you divide 2 with 4, which gives you answer of 1 by 2 or 0.5. Once again, the drawing over here is not drawn to scale, so I cannot get correct answers. This is just a demonstration of how you're supposed to be solving this question. And here, the answer is supposed to be 0.8. 3. State how a colorless substance can be made visible on a chromatogram. The chromatography paper should be treated with a locating agent. 5. Complete the table about solids, liquids, and gases. Alright, so we have the particle separation in solids, so they are touching each other. Particle arrangement of liquids is random. Similarly, type of motion of gases is also random. B. The graph shows the change in temperature as a sample of a gas is cooled. As you can see over here, the temperature is decreasing, and that means energy is being removed out of the gas, and that means molecules of gas are being brought closer together, and that is the reason this results in change of state. Since as molecules get closer together, they turn from gas into liquid and then liquid to solid. And the region where you see a straight horizontal line is the region where the conversion of gas to liquid is taking place. And this conversion over A and B is condensation. The question does not require you to answer anything else, but I'll just explain that the change over here is conversion from liquid to solid, because after condensation, that is the only change of state. C. A bottle of liquid perfume is left open at the front of a room. After some time, the perfume is smelled at the back of the room. Name two physical processes taking place. So the liquid perfume has to turn into gas to be able to diffuse through the room to be smelled at the back of the room. So the first process that takes place is evaporation and not boiling, because there is no change of temperature. And the second process is diffusion. 6a. An endothermic reaction occurs when calcium nitrate is heated. 1. Balance the equation for this reaction. So we have 2 over here, 2 over here, 4 and 1. 2. State the type of the reaction shown by the equation. Since the only reactant is being broken down to multiple products, this is a thermal decomposition reaction, because heat is also required in this reaction. B. Describe the test for a nitrate ion. So you can test nitrate ion by adding aqueous sodium hydroxide. In the solution which has nitrate ion, and then followed by addition of aluminum foil. Alright, and the positive result of addition of aluminum foil and sodium hydroxide gives the result that ammonia is produced. And if testing ammonia requires a damp red litmus paper, the positive results of presence of ammonia would be color change from red to blue. Seven, aluminium is extracted by electrolysis. Iron is extracted from its ore by reduction with carbon. What is meant by the term electrolysis? So here you're supposed to be writing the definition of electrolysis, which is B. Name the main ore of aluminium. So we have this answer as bauxite. C1. Explain why aluminium cannot be extracted by reduction with carbon. So for any element to be obtained by reduction reaction with carbon, it has to be less reactive than carbon so that it can displace this element. But since aluminium is not less reactive, in fact it is more reactive than carbon, it cannot be displaced or reduced by carbon. 2. Describe the role of cryolite in the extraction of aluminium by electrolysis. Since it decreases the melting point of aluminium oxide, it reduces the energy required to melt aluminium oxide, and that in turn reduces the cost. Three, name the product formed at the positive electrode. So the positive electrode attracts negative ions, and since this is molten aluminum oxide, the only negative ion is the oxide ion, and it forms oxygen. 4. Write the ionic equation for the reaction at the negative electrode. So the negative electrode attracts the positive ion, which is aluminium in this case. It's got the charge of 3 plus, so we need 3 electrons to cancel out the charge of 3 plus, and so the product is a neutral aluminium atom. Aluminium is used in overhead electricity cables. Give 2 properties of aluminium that make it suitable for use in overhead cable. Right. So overhead cables need to have, first off, they need to be good conductors of electricity, which is a feature of aluminium. And its low density prevents the cables from sagging down, so that is another feature. Iron is a transition element. One iron forms hydrated iron oxide when it rusts. Write a word equation to represent the formation of rust. Alright, so you're supposed to be writing all of the reactants and the products. First off, we have iron, which reacts with water and oxygen. To give the product as iron oxide. To give 2 ways in which the properties of transition elements differ from the properties of group 1 metals. So they act as catalysts and they form colorful compounds. A. Part of the synthetic polymer nylon is shown in the diagram. One circle, one amide linkage on the diagram. Right. So here is our one amide linkage. To complete the structures of 2 monomers used that react to form nylon. Alright. So we have one of the monomers having carboxylic acid group. The other one has amine groups. Three, name the other product formed when nylon is produced. This is a condensation reaction, so it produces water as the byproduct. B, items made from nylon are often disposed of by burying them in the ground. This is called landfill. Why is the disposal of nylon using landfill a problem? Because it is toxic, so the land which has nylon inside of it cannot be used for growing crops, which would be a waste. C, give the name of a natural polymer. Here you can write any polysaccharide or protein. So I'm going to go with protein over here. And that's it. We're completed with this paper. Thank you for watching.